Um, um, all right, this week is week 9. Um, so let me show you the stuff I'm going to talk about this week. So if you go down to week 9, this is the stuff for this week. As you can see, there's only one video you had to watch. I hope you guys did watch that. Right, and so it's basically, this video is on examples on one sample confidence interval. There are 4 examples I did. I will go through them briefly right now, and then afterwards I will do as many examples as possible on one sample confidence intervals. Right, guys? And as usual, any questions you guys have, please use the chat room. I'm here to support you guys. So anything, just use the chat room. Okay. All right. So let me stop this thing. Now let me change the camera. Here we are. Okay, this is the first example, example 1. Are you guys okay with this? So in this example, you have a random sample from a normal with mean theta and variance 1, right? And we want to find the confidence interval for theta. So I use the fact that the sample mean is distributed like this, which is a property I mentioned in the video on normal distribution, right? And then it follows from this that this is the case, and it follows from this that this is the case, and so on until you get to this stage, right? And it follows from this statement that this is the confidence interval for theta, right? If you can't see, I mean, if you cannot see the visualizer clearly, if it plays around like last time or last week, please let me know. I will try to do something about it. Okay. So this is example 1. Okay, and this is example 2, where you have a random sample from a normal with 0 mean and variance theta squared. We want to find a confidence interval for theta. So we start from this fact. This is a fact I talked about on the video on chi-square distribution. So if you look at this video one more time, you will see this, right? And from this fact, you can write this, and from this, you can write this, and finally, you will get to this statement here. And this, according to this statement, the confidence interval for theta is this, right? Why do we use chi-squared in Q2 instead of the following the same process in Q1? Well, you can if you use the same process in Q1, John, you will not get a confidence interval. I mean, if you use the same process in Q1, which is this one, right? You will not. That will not. That. I mean, you can try it. You can try it, and it will not give you. Well, I mean, John, I think, yeah, I mean, you can try the same process as in Q1, John, but it may give you a different confidence interval. Yeah. Okay. It may give you a different confidence interval. I think that's a good question. Yeah. But you can use, I mean, there can be, there's no just one confidence interval for one question, John. There can be like multiply different confidence intervals for certain questions, right? So in this case, this is convenient because this is a property This is a property that I talked about on the video on chi-square distribution, right? So it is convenient to use this property, Mikhail and John and Don, right? So if you use this property, you can get directly to this statement. And according to this statement, this is true. And therefore, the confidence interval for theta is this guy here, right? All right, that's example 2. Example 3 is a little bit involved. So here you have a random sample from this distribution function with the CDF given by this. And the question is to find the confidence interval for the parameter A, right? Now, this is a non-trivial example. I mean, excuse me, this is a non-trivial example in that you need to use this statistic maximum in order to work out the confidence interval. Now, if I give you a question like this in the exam, then I will give you this hint in the red box, right? That you need to use this statistics in order to work out the confidence interval. So using this, the first thing you need to do is to find the CDF of this statistics, which if you follow this process here, this is the CDF of the statistics max, right? Now, if you plot this versus Z, you should plot the CDF versus that Z, it will look like this, right? Now, excuse me. Now, what you need to do is you need to pick 2 points on the x-axis of the graph, right? Such that the area below the first point is alpha by 2, and the area above the second point is also alpha by 2. So the area in between the two is 1 minus alpha. So that's what I have done. So the first point, to determine the coordinate for the first point, you need to solve this. To determine the coordinate for the second point, you need to solve this, right? So you got the coordinate of the first point as being this, and the coordinate for the second point as being this, right? So the probability that Z lies between these two they can be non-standard, Mikhail. I mean, Michael, they can be non-standard. I mean, the questions in the exams may not be the same, as what you have learned here, right? And you look for the CDF which involves. Yeah. Okay. I mean, there can be non-standard questions like this one that you may get in the exam. Okay. All right. So anyway, let me continue. So this is the coordinate for this. The x coordinate for this is this, and the x coordinate for this point is this. So the probability that Z lies between these two is 1 minus alpha. Now, if you solve this, if you rearrange this equation in terms of A, this is what you will get. And hence, the confidence interval for A is this interval here. Okay. All right. Right. So this is a non-standard example which you may get, or you may, I mean, you may get non-standard confidence intervals in the exam. So you should be able to derive using what you learned. I mean, using what you learned, you should be able to derive non-standard confidence intervals. All right. Example 4 is this one. Example 4, you have IID log normal with parameters theta and 1, right? And so the question is to find the confidence interval for theta. So I start with this fact. If xi is log normal, then the log of xi is this. I mentioned this last week. So it follows from this that this is the case, and until you get to this, right? And it follows from this that this must be true, right? And if you rearrange this statement as a statement on theta, you will get to this, right? And hence a confidence interval for theta is this one, okay? So these are the 4 examples, guys, I did in the video. I asked you guys to watch. Okay, I hope all of you guys watched that video. So what I'm going to do in the remaining time today this review session is gonna go through as many examples as I can. Okay. All right. So let's start with example 1. I hope you can read this. If you can't read it, let me know, guys. Example 1 is this. You have a variable x that geometrically distributed with parameter p. We want to find a confidence interval for p. All right. Now, what you should do is always, you know, that the CDF, you know that the CDF of a geometric random variable is 1 minus 1 minus p power x, right? For x goes from 1 to up to infinity. Okay, this is the CD. I'm sure you did this in probability 1 last semester. Okay, now if you plot the CDF as a function of x, right, it may look like, suppose this is 0, suppose this is 1. It may look something like this, right? Okay, okay. This is obviously going to infinity, right? Now the thing is, we need to pick. This is, yeah, this should be example 5. My friend. Yeah, I'm just calling it example 1, but it should be example 5. Yeah, you're right. Now let's took 2 points here. All right, so that the area here, right, is alpha by 2, right, and the area over here is also alpha by 2, right? And we need to figure out these 2 points. We need to figure out the coordinates of these 2 points, guys. Now, to figure out the coordinate of this point, I'm going to solve the equation that the CDF is equal to alpha by 2, which implies that 1 minus 1 minus p power x is equal to alpha by 2, right? And this implies that, excuse me, this implies that 1 minus p power x is 1 minus alpha by 2. So x, you should solve this, will be log of 1 minus alpha by 2 divided by log of 1 minus p. Okay, so that's for this coordinate of this point here, right? So let me put this in a box so you can see it, what I'm doing. And similarly, to determine the coordinate for this point, right? Okay, we need to solve the equation that we need to solve this equation. So this implies that 1 minus 1 minus p power x is 1 minus alpha by 2. So this implies that 1 minus p power x is alpha by 2, right? So x is gonna be log of alpha by 2 divided by log of 1 minus p. Okay. All right, so now we figured out the coordinate of this point and this point. So what we can now say is that the area between the two, in other words, the probability that okay, You follow what I'm saying, right? So the probability that the random variable lies between these 2 points must be 1 minus alpha, right? And that's what I have said, guys, here. The probability that x is between these two is 1 minus alpha, right? Let me know if you can't see the screen clearly. Okay, I mean, this is the best visualizer I can afford to buy because I get no money from the uni. Okay, all right. So now what I'm gonna do is I'm gonna rearrange this as a statement on P. Okay, as a statement on P. So now remember, so this implies that if you multiply across by log of 1 minus P, this will be log do you see why this sign changes? Guys, talk to me, guys. Do you see why the sign changes from, because remember log of 1 minus P is a negative number. So when you multiply by a negative number, you need to change the sign around. So that's why less than becomes greater than and less than becomes greater than. Okay, right. So now I'm going to divide everything by x. Okay, right. Okay, and now the next thing I'm going to do is I'm going to take the exponential. I'm going to take the exponential of all the 3 terms, right? So this is going to be the probability that okay. All right. Now the next thing, this one actually you can simplify this. You can simplify this one and this one to the following. This will become 1 minus alpha by 2 to the power 1 over x. Okay. All right. And finally, I'm gonna subtract each term from, take away one from, I'm going to take away 1 minus each term, right? So this will become, again, the sign changes. The sign changes because I'm using a negative sign, all right? So hence, all right, so this completes the first. So this is the confidence interval for P. So this is the lower limit and this is the upper limit. Is this okay with you guys, or are you confused? Let me know. Are you okay with this example? Hello, guys. Talk to me. Yeah. Okay. Thanks. All right. So this is example 1. The next example is this one, right? Example 2, which is basically example 6, actually. Right, so here you have a random sample from a log normal with parameters 0 and theta squared, and find a confidence interval for theta. Okay, all right, so okay, the first thing to realize is that if xi is log normal with parameters 0 and theta squared, yeah, then the log of xi is normal. I think I mentioned this last week with the same parameters, right? So using the property that I just mentioned a minute ago, that this is a property I mentioned, C. See the video on chi-square distribution, right? Okay. Camera, please. It's not working. Is it blurring? Hello, guys. What's up? Uh, is it better now? Is it better? Hello, guys. Is it better now? Hello. Is it better? Not really. I mean, this is the best I can do, guys. Sorry about it. Okay, sorry. I mean, I can't do better than this. Sorry. Thank you. Thank you for understanding. Thank you. All right, so this is from the video on chi-square distribution. All right, so this implies that the probability that okay. All right, so because of this statement, this must be true. Right now, what I need to do is to rewrite this as a statement on theta. Right. Okay, so that's what I'm going to do. I'm going to the first thing I'm going to do is to divide. All right, before I do that, let me do it slowly. Let me do this slowly. Okay. All right, and next thing I'm going to do is I'm going to divide each term within the brackets by this, right, which is a positive quantity. All right, so this will become All right. Okay. Now the next thing I'm going to do is I'm going to take the reciprocal of each of the three terms, right? So that will change the sign, right? So when I take the reciprocal of this is going to be so you see the sign is changing, as you can see. All right. Okay, guys. And the next thing I'm going to do is I'm going to take the square root of each, because the question is to find the confidence interval for theta, not theta squared, right? So, and theta is a positive number because it represents standard deviation. All right. So I'm going to take the square root of every term in the brackets. So the square root of all right. Okay, guys, you follow this. So hence, the conclusion is the following. Hence, a 100 times 1 minus alpha percent confidence interval for theta is the interval from so the lower limit is this. This is the lower limit, and the upper limit is all right, this is the upper limit. All right, guys, so this completes the second example. John, yeah, whether it's equal or not, less than or equal to does not matter, John. So it can be, yeah, it doesn't matter whether you put equal or, sorry, strictly less than or less than or equal to, doesn't matter. Don, I don't understand your question. What do you mean, Don? Is it not the other way around? What do you mean? Oh, yeah, sorry, you are right. Yeah, you're right. Yeah, I'm being stupid today. I don't know why. This should be the other way around. Yeah, you're right. Yeah, you're right, Don. Thank you, Don. Yeah, you're right. Thank you, Don. Yeah, thank you. Yeah, so this should be alpha by 2. Should be 1 minus alpha by 2. Right. Okay, thank you. All right, are you guys okay with this example? Any other questions? Yeah. Okay, let me move on to the next question. So this is example 2 I've done so far. Example 3 is gonna be this one, right? So here you have two variables, x which is normal with 0 and theta squared. Y is 0, normal with parameters 0 and p squared. They are independent random variables, and the question is to find a confidence interval for the square root of a squared plus b squared. Right, now let me write it down. X is normal with parameters 0 and a squared. Right, Y is normal with parameters 0 and b squared. Right, now, you know, we learned this. If you look back in the video on the normal distribution, right? What is the distribution of x plus y? X plus y will be normal with parameter 0 and a squared plus b squared. You know that, right? Or don't you? Yeah. Okay, so this implies that x plus y, x plus y divided by the square root of a squared plus b squared will be standard normal, right? Okay, this is basic standardization, and this implies that the probability that um, okay, is this, yeah. All right, now this implies that the probability, I'm going to divide each term here by x plus y. Yeah, so it will be okay. All right. All right, and the next thing I'm going to do is I'm going to take the reciprocal of each. Okay. Now, this is a positive quantity, so you would expect these to be positive too. So this is going to be okay. All right, you see what I've done. Okay. So hence, yeah, is x plus y. X plus y is just the sum of these random variables, Hank. X is normal, y is normal, so the sum of the two random variables is also normal. I mean, that's the thing that we learned in if you look back in the video on, there's no xi, yi, my friend, here. We only have one variable, x and y, not two. We don't have xi or yi. We just have one x and one y. So we are only talking about x plus y, not xi or yi, my friend. So, okay. So the confidence limit, so sorry, the confidence interval is this, yeah. The flip of the, all right, this is what I have done here, guys, is that from this line to this line, I have taken the reciprocal, that is, you flip this to this, and the same thing here, you flip this to this, you flip this to this, and you need to change the inequality, right? Because whenever you flip something, you need to change the inequality. So the less than becomes greater than, and the less than here comes greater than. You know that, right, don't you? Like if you're flipping, say, for example, if you flip, say, suppose you have, excuse me, suppose you have alpha is less than beta, and alpha and beta are positive, right? Then 1 over alpha is greater than 1 over beta, right? I'm sure you know this, right? So that's what I have used, guys. Yeah, that's what I have used from this line to this line. Okay. Okay. All right. Any other questions, guys? Yeah, you can do that, John. Yeah, you can change this to minus of this. Yeah, I just left it out. Yeah, you can do that, John. Yeah. All right. So this completes example 3. Okay. Now let me move on to the next example. This is example 4, right? So here we have two variables, x, which is this, and y, which is this, yeah. And we want to find a confidence interval for a plus b. No, I don't think you flip the inequality if the signs are different. I don't understand. I don't think you flip the inequality. So why in example 2 of week 9, we didn't change the signs? Example 2 of week 9, which, just a minute. Which one are you guys talking about? Which example 2 of week 9? This is, let me go back just a minute. You mean this example here? Yeah. In example 2 of week 9, which is this example, I actually did flip. I mean, if you see it clear, I did flip the inequality here, Alexandra, because this goes to the left-hand side and this goes to the right-hand side. So I actually did flip. Okay. Yeah. I hope you get it right. Okay. The notation about you mean the notation about these percentiles of the normal? Yeah, you need to look in the video on, there's a video on percentiles which I did last week. So could you please have a look at it? It explains how to read the percentiles. I mean, how to read the percentiles of the normal. So the notation, please look at the video for week 8. It explains the notation for the percentiles of the standard normal. Okay. Right. Okay. Can I continue with example 4, please? Okay. Example 4 is this one. So this implies that x plus y is normal with parameters a plus b and the variance equal to 2, right? Okay. So this implies that x plus y take away a plus b divided by the square root of 2 is standard normal. Okay. All right. So this implies that the probability that is this, yeah. All right. Okay, guys. Now I'm gonna rewrite this as a statement on a plus b. Okay. So the first thing I'm gonna do is I'm gonna multiply everything by root of 2. So okay. And the next thing I'm gonna do is I'm gonna take away the x plus y. Uh, okay. And if you do that, this will give you, all right. And the final thing I'm going to do is I'm going to multiply every term by -1, right? So whenever you multiply by -1, you need to remember, you need to change the sign. Okay, so this will become root 2 less than will become greater than a plus b. All right. Okay, so be done. So hence 100 times 1 minus alpha percent confidence interval for a plus b is, the lower limit is going to be minus root 2. Okay, the upper limit is going to be okay. All right, so this completes example number 4, or example 8 actually. All right, are you okay with this? Any questions? Well, hello guys, talk to me. Are you okay with this example? Okay, right. Okay, so this is example 4. The next example I'm going to do is example 5, which is this one. So here you have a variable x that has a CDF given by this. And the question is to find the confidence interval for b, right? So to do this question, it's always, right, the CDF is, this is probably the last question I have the time to do. Right, it's always a good idea to plot the CDF f of x versus x, right? I think it will look something like this, I guess. So this will be 1, this will be 0. Now what you need to look for are 2 points along the x-axis, such that the area to the left of the first point is alpha by 2, so this area, and the area to the right of the second point, that is this area here, is also alpha by 2, right? Okay, so we are looking for, and these 2 points, the area in between these 2 points should be 1 minus alpha, right? So to solve this, to solve for this point, right, you need to set, this, right? So this implies that and this implies that we should solve for this. Let me do it quickly because I'm running out of time. So log, so x, sorry. Okay, so this will be, you should take the log one more time and then solve for x. You get all right, this is what you will get. Okay, and you should solve for this point using this, right? You will get, you should follow the same procedure as in the first box. You will get this. Okay, so the probability, so I'm skipping some steps because I'm running out of time, guys. So the probability that the variable x lies between x, between this point and this point, right, is equal to 1 minus alpha, right? Okay, now you need to rearrange this as a statement on B, right? Because that's what we are looking for. Now, if you do that, I will do it quickly because once again I don't have the time. So I will, if you do this as a statement on B, right? This is what you will get. The lower limit will be x plus right, and the upper limit will be x okay, right? So this is the, so the conclusion is that, so hence 100 times 1 minus alpha percent confidence interval for B is as follows. So the lower limit is going to be right, and the upper limit is going to be okay. All right, so that completes example. This is example. I'm sorry I have done it quickly because of the time, right? But I hope you followed what I did. Are you okay? Hello guys, talk to me. Are you okay with example 5? Yeah. All right guys. So There's a tutorial at 11 o'clock UK time. All right, so I will talk to you shortly in about 10 minutes time. Okay, so take care and have a good day wherever you are. I will talk to you shortly. Okay, thank you. Bye.